Look at categorical data. Again, we may have two sets of variables that we're going to look at. Well, no matter whether I'm looking at categorical or quantitative data, there's a couple parts that we have to be able to recognize. One of them is the difference between what's called an explanatory variable and a response variable. So an explanatory variable is one that's going to help us predict or explain the changes in a response variable. I'll come back to that here in a second. So that's one of the types of variables within our categorical or our quantitative situations. When we talk about the explanatory variable, we're talking about really the values that are on the x-axis. Then we have the response. So a response variable, that's what's going to measure the outcomes of the survey. That part is going to go on the vertical axis or on the y-axis. So for instance, if I'm talking about categorical situations, maybe on the explanatory or the explanatory variable or what's on the x-axis might be like when we did surveys earlier, you may have asked what color are your eyes? Well, those options would be on the x-axis, on the horizontal axis. The response would be how many times people answered that, and that's what went on the y. When we get into quantitative, then it may be, okay, what's happening here that would affect this? A lot of times, if you're collecting data, it may be the amount of time and what happens, something like that. And we'll get to that later on today. But the explanatory, the big thing is the explanatory is going to affect the response. And the explanatory is going to be on the x, the response is going to be on the y. So let's say I gave you this situation, and we were going to try to pick out, well, what is the explanatory in this situation? In other words, what would affect the other? So the two variables I'd be focusing on, I took a survey, and within the survey, I kept track of what class in school the person was. So were they a freshman, a sophomore, etc. And then I asked whether or not they were allowed to stay up past 11 on a school night. Well, which of these two things do you think would affect the other one? Because that's what we're looking for when we talk about explanatory. Would how old a person is affect how late they get to stay up? How late they get to stay up affect how old they are? Which one of those do you think would be the explanatory? Yeah, probably most likely how old they are, right? So the class in school is probably our explanatory variable there. Because again, being a senior may affect how late you get to stay up. But if I get to stay up till midnight, that doesn't mean that I'm automatically a senior. Like I said, the reason that's important is as we start doing graphs, we got to know which one goes on the x and which one goes on the y. All right, so categorical data, how are we going to display it? Well, we don't have a whole lot of options actually when we're looking at two variables. But one of our options is what's referred to as a segmented bar chart. The segmented bar chart, like it says, displays the possible values of a categorical variable, but it's going to break it into segments. If you remember back when we first did categorical, we really only had two ways to display them. We could do bar charts and we could do pie charts. Well, when we have two variables or two different sets of categorical data, we're going to stick with that bar chart. We're just going to divide it up and do it into segments. So I took this example from the book, so made it so it didn't go really exciting. But what we're going to try to do is we're going to try to display this data and we're going to do it with a segmented bar chart. So here's the data that they kept track of. They looked at two variables. They looked at on the Titanic, they looked at what class of travel. So did they travel first class, second class, or third class? And then the second thing they looked at was the number of people who survived and the number of people who did not. So the two categories or two variables were both categorical. It was class of travel and it was survival status. Well, we're going to try to break this, like I said, into the segmented bar chart. So if I think of those two variables, I got to identify which one I think, first of all, would be the explanatory variable. Which one would I want to put on the x-axis? Well, if I think about those two things, would how they traveled, first class, second class, third class, would that affect whether they survived or not? Or would whether they survived or not tell me that they are first class, second class, third class? Which one do you think would have a bigger effect? How they traveled, would that affect whether they survived or not? Whether they survived or not, did that tell me what ticket they bought? Yeah, probably what class of travel is going to affect whether they survived or not. So we're going to put the class of travel on the x-axis when I set up my bar chart. So just like we did bar charts before, we'll have an x-axis and a y-axis. But along the bottom, I'm going to have my three classes of travel. We had first, second, and third class. So again, once we decide what the explanatory variable is, we'll put that on the x-axis. Well, the next thing we're going to do is we're going to break these totals into, in this case, the two categories, the survival categorical category and the category of the ones that did not survive. But what we're going to do is we're going to break them down by percentage. In other words, we're going to figure out of the first class travelers, what percent survived, what percent did not survive. So our table already gives us the number that survived, and it also gives me the number that were in first class. So I'm going to take that 197 that survived, I'm going to divide it by 319. So if I take 197 and I divide it by 319, and usually going to the nearest percentage is okay. Well, I get 61.8, so I'm going to call this 62%. Now, there's only two categories here. There's the survived and didn't survive. And I know those two together should add up to how much, percentage-wise? 100%, right? So I don't really have to do any calculations on the other one as far as percents, because if 62% did survive, then the other 38 did not. Then I'm going to do that for each class. So I'm going to go to the second class. They had 94 that survived, had a 261. So that's roughly 36%. And again, I know it has that up to 100, so that leaves me 64%. And then finally, we have the third class, so 151 out of 627. That's 24%. that'll leave you with 6. So however many categories there are there, we're going to break them into the percentages for each one. Well, for our display, we're going to put the percentages here on the y-axis. And we know that the percentages for each case always added up to 100. So I need to make the y-axis go up to 100. So you can set up whatever interval you want. Probably go by 5s. Well, the nice thing about segment and bar charts is initially I'm going to make bars that go up to 100% for all those categories. Because I know all of them had that up to 100. So I'm going to go to the first class here. I'm just going to make a full bar that goes up to 100. Same thing for second class. And same thing for third. So in a segmented bar chart, all our bars should have the same height initially. Well, from there I'm going to segment or break it up into the percentages that we found. So for first class, we said the percentage that survived was 62. So I'm going to go to that 62% mark. I'm going to break it off at 62%. But I want to distinguish my two categories. So somehow I'm going to mark this differently than this one. And what I mean by that is maybe I make stripes, maybe I color it in. If you happen to be using colored pencils, you can do a different color. There's something that distinguishes that section from the other section. Now, the nice thing with this one, there was only two categories there. It's either survived or didn't survive. So I don't have any extra work to do because whatever's left should be that second category. And then I'm going to do the same thing for second class and the same thing for third class. The second class will go to 36. Break it off. And since I did the percentage that survived on the bottom of the first one, I want to make sure I do it on the bottom of the second one as well. And finally, the third class was 24%. Now, we know what all those things represent, the stripes versus the non-colored in part, but I need to tell somebody else what those represent. So I also want to make a key to this. So my key might be, all right, the striped part was the survivors. And then the open part was the ones who did not survive. So always make sure you include a key so somebody knows what section is marked. then there's one other thing I haven't put on there yet that I always have to put on there, and what's that? Yeah, I need a title of some sort. So whatever you want to call it, survival rate on Titanic. And so that'd be a segmented bar chart. And that's really the only way that we're going to be able to display multiple categorical data. This one, like I said, it was nice because there was only 2 categories. If I were doing one and maybe I had 3 categories, maybe there was a yes category, a no category, and a maybe category, something like that. And I got my results for something and I found out that this was 40%, this was 30, and this was 30. And I started making my bar graph with those 3 things. Well, what I'd have to do in that instance, I'd still go up to 100, but then I'd have like a running total as I went. So like the yeses would go up to 40, wherever that is. My no's would then go up to how much? 70. And then the rest would be our maybes. Which, if I were doing this, now I need 2 distinguishing ways. So maybe I would color one of the section in, maybe I'd stripe a different section, maybe I'd keep the 3rd section open. Okay, so if you have more than 2, it's a little bit tougher because you kind of have to keep a running total. But 2 is nice because you don't have to worry about that. All right, so that's one thing we'll have to be able to do is actually display it. The second thing for this section is once we have that graph, sometimes we want to look and see, is there what we will call an association between those variables? This is kind of the analyzing part of our graph. Well, I would say that there is an association between 2 variables. If knowing the value of one variable helps me predict the value of the other variable. If I know the value of one variable, but that doesn't help me make any predictions about the other one, then that means those 2 things are not associated to each other. So let's take this example. And so I have the segmented bar chart essentially that we just made. And what we're going to try to figure out is there an association between the class of travel and the survival rate? In other words, do we think how they traveled, 1st class, 2nd class, or 3rd class, did that affect whether they survived or not? So, Caleb, what do you think?
I think it did.
Yeah, it definitely did. Why would you say it did?
Because for one thing is it could have been like where 1st class was seated at, because like if I'm not mistaken, then go like 1st class was like closest to the 2nd class was going third was at the closest to the actual water level.
Right, exactly. So 1st class had easier access to get off, right? Versus 3rd class, it was more difficult. Let's think about how the graph shows that, because you're right, it did have an effect on there. If I look at that graph there, what about being in 1st class told me that that was actually affecting their survival rate more so or in comparison to the 3rd class?
There's a higher percentage of survivors.
Yeah, if we just looked at the percentage of survivors, you're right. The percentage of survivors were higher in 1st class than they were in 3rd class, and even in 2nd class versus 3rd class. So there was definitely an association because the percentages were higher as far as survival in the 1st class. Well, what would that graph have to look like if there was not an association? In other words, if I wanted to show somebody that, okay, it didn't matter whether they were first, second, or third, what would it have to look like?
You can have one that was first would be like 60%, and second could be like 70%, and then third could be like 40, they just get all the
Okay, so, but if we did have that, you said like 70, 60, 40. If that happened, and I said, okay, you get to choose one of those classes, knowing those percentages, would you choose one over the other?
Yeah.
Yeah, probably. So that would probably go back to having an association. What would be a situation where it wouldn't have an association?
Where the numbers are close to the others, like.
Yeah, maybe, and those numbers would have been fine. Maybe if I had this, and I said, okay, you get to choose which class of travel you have, knowing those percentages, would you care which one you chose? No, other than probably you want to go first class, but as far as survival is concerned, you wouldn't care because they're all the same. All right, so if you have a situation where there's no association, that means the percentages are going to be basically the same. Now, that doesn't mean they all have to be 50-50. They just all have to match as far as, in this case, the survivors. But any variation from being the same tells me there is an association between these two. Did you have something happen?
No, I was just gonna say, like, if the two sections, like, if the two categories were even on this.
Okay. And that would be an example. It doesn't have to be 50-50, but that would be another example. All right, so we got to be able to make a segment of our chart, and then we have to decide, do we have an association between our variables? All right, that's basically it for section 2.1. So these are the book problems from 2.1 that I'd like you to do. These problems are going to be due on Monday. That's our next class day. Those will be due. What I'm going to do is I'm going to give you about 25, 30 minutes now to work on these, to start working on these. And then we're going to come back together and I'm going to start looking at the next section because we got to cover a couple things today. So we're going to look at how we can display two quantitative variables. Then after that. All right, but right now I'll give you some time that you can start working on these problems.